Hello everyone, my name is Simon and I'm very excited to present you on my final project research on quantifying the economic value of urban greenery with geospatial double machine learning. And for me, I am a master candidate in data science at Harvard Extension School, and I'm also a PhD candidate in data science and the urban planning at the University of Cambridge. So from my own background, I really find the urban greenery is very fascinating to research about, and it can include the parks, urban parks, street trees, green roofs, front green corridors. And in terms of urban planning design, the urban greenery really matters because it changes how we experience the public spaces and makes the spaces much more beautiful in terms of the aesthetics values and much more enjoyable for us to live. But in the academia, there are still some gaps about it, and because there are not so many quantitative and micro scale studies on that connect the greeneries to the local economic vitalities, and the mechanism is not very clear. So we are not too sure that the urban greeneries attract economies and night and light activities in terms of the aesthetics values, or it's especially in hot cities, it can cool down the local temperature, and therefore people will just tend to concentrate more on the cooling areas in the hot area. And so in terms of that one, I used a technology named double machine learning, which is a causal inference framework, which uses machine learning to flexibly model high-dimensional confounders while still estimating the treatment effects with orthogonalization and cross-fitting to reduce the bias. And so I'm going to introduce the variables here very quickly. So we do have the outcome variable, which is Y nighttime light activities, and the treatment is NDVI, which is a vegetation index, and mediator going to be the land surface temperature. We also have a set of the control variables like the building indexes, water indexes, population densities, and the fixed effect for the cities and the years. And with the double machine learning, I can estimate the total direct and indirect effect using the framework. And for the and then I actually constructed two types of the models. And the first one is the MLP based double machine learning, which is a simple neural networks. And for this one, we do observe that all the coefficients in terms of the total effect, direct effect, and the indirect effect are all positive, and they are all statistically significant as well. So which confirms that urban greeneries and does attract some economic activities during the night times in terms of the nighttime light intensities, and they are and both and also the mediated land surface temperature also does its job as well and contributes to attracting more nighttime light activities to the surrounding urban green areas. But for the second part, I also constructed the graph neural networks, which take account of the sort of spatial agencies between the different nodes, which is actually the polygons of the cities. And all the others are same, but the indirect effect is not statistically significant anymore, as we can see here. And so the main results will be that urban greeneries can indeed attract much more nighttime light activities, but the temperature may be more due to the spatial correlations and autocorrelations, and it's not going to be very significant in terms of attracting nighttime lights. Thank you.